Yes, to you. Good evening and welcome to my live broadcast. Where you are watching from. Question, please let me know your question. So let me know where you are watching from. Yes, welcome. Where are you watching from? Welcome to the live broadcast. Thanks for joining my live broadcast. Where are you watching from? If you have any question, please let me know. Tribe of Enoch. You're watching from Glasgow. Thanks for joining, Mr. Enoch. Thanks for joining. You're watching from Glasgow. Mr. Carlos, hi, hello to you. Infinity, you're watching from South Africa. Mr. Enoch, you have few questions, okay? Sunday, you're watching from Port Harcourt. If you need my WhatsApp number, please just check my channel description. You will get my WhatsApp number. Mr. Fasasi, watching from Lagos. Mr. Kinsaya, you're watching from Lagos. Mr. Victor, you're watching from Tanzania. Kanji, you're watching from Ogbomoso. Lisa, you're watching from South Africa. Zini, you're watching from Nigeria, from Kano, Nigeria. Thank you all for joining. Mr. Rocks Engineer, you're watching from Zimbabwe. Wow, thanks for joining. Welcome to the live broadcast. Thanks for joining. I'm expecting your questions. If you have any question, please drop your question. Please drop your questions. I'm waiting. Just excuse me. All right. Mr. Polok, you're watching from Jamaica. Mr. Mohammed Damladi from Lagos. Mr. Okay, Tribe of Enoch. Is it possible to become a solar engineer without prior knowledge? You can become a solar engineer. You definitely start from the foundation, the basic foundation. So you can, depending on your determination. Excuse me. You can become a solar engineer even without the experience. It starts from somewhere, so it's step by step. It's for you to know the basic foundation. Start with the basic foundation. It's not difficult. Once you make up your mind, you'll be able to do it. So you can. Engineer Paul, watching from Nigeria. I'm waiting for your question. Mr. Muhammad, you're asking how can I get the handout or the handbook? There's a link. There's a link on my YouTube channel. You can buy or purchase the PDF from that link. It's seller, so you can get it from there, or you contact me on WhatsApp +234 810 878 1450. You can contact me through that line. For the one that is fast, check my YouTube channel, the channel description. You'll see my WhatsApp contact. Mr. Callas, you're watching from Somalia. I'm good. Thank you for joining. Mr. Akanji Joe, if inverter DC input is 12 volts, 133.3 amp, what does it mean? What does it mean? It means the input voltage of that inverter is 12 volts. What it means is that if you have a 12 volt battery, you can connect that inverter to that single 12 volt battery. But if you have 6 volt batteries, if you have 6 volt batteries, it means you need to connect those two 6 volt batteries in series to give you 12 volt, because the nominal voltage of that inverter is 12 volts. We also have 2 volt batteries, so you need to connect those batteries, I think 6 of them in series to give you 12 volt. That is 6 times 2 to give you 12 volts. So the 12 volt there is telling you the nominal DC input voltage of that inverter. That is the required voltage, the operating voltage, DC operating voltage that the inverter needs to operate or to function, because the inverter takes the DC from the battery and converts to AC to power AC appliances. So that 12 volts is the voltage, the nominal battery bank voltage that that inverter can operate. It means you cannot connect that 12 volt battery, I mean an inverter, to a 24 volt battery bank or a 48 volt battery bank. It will only operate if you connect it to what's it called, to a 12 volt battery bank. Then the 133.3 amps, I believe, is the maximum amps or current that the inverter can draw from your battery. Is the maximum current that the inverter will take from the battery, depending on the loads you connect to the inverter. So that is the maximum amperage the inverter can take from the battery. Mr. Infinity, I would like to know how to measure the load to know the size of inverter that I must use. For you to measure your load, you need to know the power rating of your load. You can do that by looking at the nameplate or the specification sheet of the load or the appliances. Maybe you have a fan, you have a TV, you have a refrigerator, you have an air conditioner. You need to check the load, the power, the total power consumption of those loads. So if you know the total power consumption of those loads, to choose the size of inverter, you divide the total power of those loads by 0.8, 0.8. It will give you the size of inverter you'll be using. For example, you have a TV and the TV is 50 watts. Then you have another appliance, maybe a blender, and that blender is 500 watts. Then you have another appliances or another load that is rated 200 watt. You will just sum, that is, you add all the loads of those appliances, each of them, you add them together. Then the total load, you divide it by 0.8. Whatever value you have is the size of inverter you need. But if you divide and the value you have, you cannot get that size of inverter in the market, then you choose the nearest value. For example, after dividing, you are having like 1,350 or 1,400. You just go for a 1.5 kV or 1,500 watts inverter. So I think can 4-ton AC run on a 12 kilowatt hour inverter? Can a 4-ton AC run? Depends. You look at the specifications of the, what's it called, of the AC. Look at the specification, the starting power, what's it called, the maximum power draw or the running power of that inverter, of the air conditioner. uh it will, the 12 kilowatt inverter is a big inverter, so you need to check the power rating of that air conditioner. So another way you can know the power rating or the power consumption of your load is by using I don't have it here, by using an energy meter. Meter is not here. You use an energy meter. By using an energy meter, you'll be able to measure the power consumption of your load. So the energy meter will tell you what your loads are consuming. Sorry, my Wi-Fi is not charging. All right. So the energy meter will tell you what you are consuming. So that one is straightforward, and your reading or your value will be accurate. Okay, Sunday Emmanuel. So I helped me my boss. So I helped me my boss to purchase your book yesterday on seller, and we make the payment, but he called me this evening that he hasn't seen the book. Please contact me. Just call me. Sorry. At times, it's network problem. After payment, you will not be able to download it. But most times, it takes some days. Seller will now send a soft copy to your email. But please contact me on WhatsApp 0810 878 1450. 0810 878 1450. Just contact me, send me the receipt, the details, probably the phone number and the email you use in purchasing it. I will send you the soft copy. Please, I'll send you the PDF copy. Don't be offended, please. Sorry for the inconvenience. All right. Then I want to explain AC, DC, and breakers connection. Explain it how AC and DC breakers, I believe that is what you mean. In a PV system, we have the DC side and the AC side. The DC side is from your solar panels down to your charge controller to your battery bank. Then from your battery bank to your inverter, they are all DC. Unless you're using micro inverters, those one you connect them directly from the solar panels and they convert the DC to AC. So when you're sizing either breakers or fuse, you should know whether you're using it for whether it is AC or it is DC, so that the breaker will function efficiently. So what is your question again? Uh, I can't see the question. Not seeing the question again. So when connecting the system, does the charger, controller, battery, and inverter all have to be the same voltage? It depends. When you're connecting your solar power system, from your solar panels to your charge controller, you may have very high voltage, depending on how you connect the solar panels. If you connect them in series, you have high voltage from the solar panels to the charge controller. That is if you are using an MPPT solar charge controller or a hybrid inverter. So you'll be having high voltage. But from your charge controller to your battery, the voltage will be low, and that voltage will correspond to the charging voltage of your battery bank. Then from your battery bank to your inverter, the voltage will depend on the DC input voltage of the inverter. Then from your inverter to your load, after converting from DC to AC, you'll be having, depending on your country, you'll be having either 110 or 220 volts. So the voltage may not be the same depending on your system configuration, depending on the components you are using, depending on how you decide to size the system. Solar panels to charge controller, MPPT or hybrid, their voltage most times is very high. You may have up to 200 volts or 300 volts, but you're using it to charge a 48 volt battery bank or 24 volt battery bank. So the voltage most times is not the same. It's only the same if you're using a PWM charge controller, because for a PWM charge controller, the voltage from the solar panel to your battery bank is most times always the same, almost the same. Then the current also is the same. what you from your solar panels to the controller, that's PWM, from the controller to the battery bank is the same voltage. But MPPT will take high voltage, a low current, then from the controller itself to the battery bank, you have high current, low voltage. So it depends on what you are using. Please like the video, like the live stream. Please just click on the like button. You can also share. Please, if you need my contact details, just go to my profile. Go to my profile, the description. You see my number there. Okay, Mohammed Danladi. At what point do you use the bus bars? Um, you use the bus bar if maybe um okay. Let me see if I can draft something. Maybe uh you have let me just draw it. You have two charge controllers. Then you have positive bus bar and negative bus bar. Then you have your battery. Then you also have your inverter here. So I don't know if you'll be able to see it. So if you have I will not be able to see it. I don't know how to explain it. Um where you need a bus bar is you have positive bus bar, then you have negative bus bar. You use bus bar when you're connecting many terminals, to the bus bar is like a distribution point. So you have your inverter, you have your charge controller, maybe you have two or three solar charge controllers. Then you have your battery. So the positive of your charge controller, the positive of your inverter, and the positive of your battery will go to the positive bus bar. Then the negative of your charge controller, negative of your battery, and negative of your inverter will go to the negative of will go to the negative bus bar. So it's like a distribution link or a distribution point or like a junction where all the positive will come there, all the negative of charge controller, battery, and inverter will come. It's like a joint a junction. All of them will assemble there. And the inverter will take its power from the positive and negative bus bar. The battery will also take its power from there, whether you're charging or you're discharging. So that is where you need a bus bar. It makes the installation smooth so that like some they will connect both the battery, charge controller positive and inverter positive. They will connect it to the terminal of the battery. Most times, it makes the terminal of the battery to become hot, and the those cable locks you're using, you're increasing, maybe increasing the resistance. So if you use a bus bar, you're freeing your it's like you're making the battery to be free of all those stress of bringing all the terminals to the terminal of the battery. That is, the battery will be at the receiving end. But if you have, it's like all the positives will tap from the positive bus bar, all the negative will tap from the negative bus bar. So it makes the installation looks nice and smooth. Mr. Julius, you need more explanation on how to connect solar to protective device like your DC, AC, and breaker. These are practical things. We cannot say them theoretically. Mr. Enoch, the name of what book is Usman Okata. Can 3.5 kilowatt solar panels charge 15 kilowatt hour battery? Using solar panels to charge a battery or any battery pack depends on what you are consuming, your daily energy consumption. So, what do we have there? 3.5 kilowatts. 3.5 kilowatt is 3,500. So, depending on your daily energy consumption, you can use them, and also the DOD of the battery. So between 5 pieces or approximately 6 pieces to 10 pieces of 600-watt solar panels. These panels can charge your 15 kilowatt hour lithium battery, and also depend their peaks on hours is higher than somebody who is in southern Nigeria. So depending also on your peaks on hours, your daily energy consumption, and your what's it called, your your uh your peaks on hours, your daily energy of the battery. These are the things you look at. You take into consideration when you're calculating the number of solar panels that can charge the battery. How many 12 volts, 200 amp hour make 2.5 kilowatt hour? Just multiply 12 by 200. 12 multiplied by 200 multiply by 12. You're already having 2.64. That is 220 multiplied by 12. You're having 2,600 kilowatt hour. But if you're comparing it with the lithium battery, this 2.6 kilowatt hour, you can only use 50% of it, which is 1,320. But for the lithium battery, some of them you can use the whole of this, all you can use the complete energy. That is, if you are discharging it at 100% DOD, you can use the complete 2.5 kilowatt hour because the DOD is high as compared to lead acid batteries. So in terms of energy storage, they are the same. But when it comes to DOD and circles, depth of discharge and circles, the lithium battery will perform better. Question. Let me see if we have more questions. Yes, Mr. Moses Crown, have I answered your question? Mr. Usman Okatahi, have I answered your question? Please let me know. Thanks for joining. Very good joining. All right. No questions again, I believe. No questions. So if you want to contact me, just go to the channel description. You will see my WhatsApp link for plus 234 8150 plus 234850. So I'm not seeing any question again. We'll call it. Okay, thanks for joining. Uh, I'm grateful for having you as my subscribers. Those who have not subscribed, please